Yeah. No, never. All right, guys. So what we're doing now is we are continuing with sketching, but now what we're going to do is we are going to sketch with holes in the graph. Yeah, like an open circle somewhere. Yeah, let's see. So we are, no. Don't worry, I'll show you. Sketching rational functions. What's wrong?
That's a big font.
Yeah, I'll make it smaller when I get to the notes. It's all right. So let's look at what we have. Let's say we have y equals x squared minus 2x over x squared minus 4. We are going to simplify if possible. Okay, so what do I mean when I say simplify the function if possible? It means if I can do any kind of factoring, I'm going to. So in the numerator, can I pull out a GCF of x? And then I'm left with x minus 2. And in the denominator, I can factor x squared minus 4. That's a dot. That becomes an x minus 2 and an x plus 2. Yeah, which ones can we cancel? Because it's the same exact expression on top and bottom, that's going to be, we can cancel that out. But because we canceled out an x on the bottom, I'm going to put a little star here. We cancel out, or cancel an x minus 2 in the denominator. So there will be an open circle. I'll write circle actually, open circle at x minus 2 equals 0, which makes it x equals 2.
So if it doesn't cancel out, we just do it normal?
So if it doesn't cancel out, that means we'll have an asymptote, right? But if it does cancel out, that means we're going to have an open circle. All right, now let's go through and find all of our different things. So part A, we're going to find our domain. Now for domain, use original function. Okay, what do I mean when I say use original function? It means use the function before you've simplified. So we're going to have y equals x squared minus 2x over x squared minus 4. And we know the domain is affected when there's a variable in the denominator. We know the denominator cannot equal 0, so we're going to take x squared minus 4 cannot equal 0. This becomes an x plus 2 and x minus 2. So x plus 2 cannot equal 0. X minus 2 cannot equal 0. So x will equal cannot equal negative 2, and x cannot equal positive 2. That's our domain. So it could be any other number except negative 2 and positive 2. So the only category we use the original function on is the domain. Every other category, the domain and the wholes, technically. Every other category, we use the simplified version. So let's keep going. Part B, vertical asymptote. So we're going to use simplified version. So we have a vertical asymptote, but we're using the simplified version. So we know there's going to be a vertical asymptote where the denominator is set equal to 0. So we know there will be a vertical asymptote at x equals negative 2. So here's the new one. Here's the new part of all of this. See. So a whole occurs when a variable in the denominator is canceled out. We canceled out x minus 2 in the denominator. Therefore, a whole will occur at x minus 2 equals 0. So what does that mean? X will equal 2. But we're not done. We now need to find the y coordinate that goes with the whole. So write this down and then I'll show you. Okay, so how do we find the y coordinate? What we're going to do is use the simplified function. So we have x and then y equals x over x plus 2. And now we're going to plug in our value for x, which is 2. So y will equal 2 over 2 plus 2. So y will equal 2 over 4, which is a half. So now our whole will be at the point 2 comma a half. It's a lot of work there. Now remember, the whole only occurs when? Good, when you cancel an x out of the denominator. A whole only occurs when you cancel an x out of the denominator. If you're not able to cancel an x out of the denominator, there will be no whole there. Okay, so we did the vertical asymptote. We did our whole. Let's go to our zeros. Again, for the 0, we're going to use the simplified function. So we have y is equal to x over x plus 2. How do we identify a 0? We set the numerator equal to 0. So we have a 0 at x equals 0. Now we're going to talk about horizontal or slant asymptotes. And again, we're going to use the simplified version. So I'm going to take the limit as x approaches plus or minus infinity of x over x plus 2. Now we take the most influential on top over the most influential on the bottom. So we are x over x, but what's x divided by x? 1. So what are we going to have? A horizontal asymptote at y equals 1. What am I going to ask now? Does it cross? Am I going too fast? A little bit? Okay, I'll let you all catch up. Move up to like there. Okay, I'll let everybody catch up. We're good? Okay, so now we're going to ask ourselves, does it cross? So once again, we use the simplified version. So we're going to take x over x plus 2 and set it equal to 1. We cross multiply, so we get x equals x plus 2. When I subtract the x's, they both cancel. Does 0 equal 2? No. Does this cross? No. We are now ready to sketch. Can I go to my sketch? Yeah? Okay. Okay, so what's going on here? Let's go through. We had a vertical asymptote at x equals -2. We have a horizontal asymptote at y equals, what was it? 1? 1. We have a 0 at x equals 0. And we have a hole at the point 2, comma, a half. Okay, so let's see where that is. So we go over 2 and then up a half. So an open circle right around there. Now we create our sketch. We understand what's going on in this area, right? We understand what's going on to the right of the vertical asymptote. So I really exaggerated that open circle, but you guys get the gist, right? So it goes like that, meaning this point in our graph is undefined. This point in our graph is undefined. Do I know what's going on to the left of the vertical asymptote? No. So how am I going to figure it out? We're going to test the points. So I'm going to test. And of course, we're going to use the simplified version. Y equals x over x plus 2. And what point am I going? What x value am I going to test? -3 is great. So y is equal to -3 over -3 plus 2. So y will equal -3 over -1, which is +3. So what does that tell us? It tells us I'm going to be up here, right? Since I'm going to be up here, we're using the asymptote. We're letting the asymptotes guide us. And it looks something like that. Right, I want to show you on Desmos.
So you notice up there, because like if the y is 3, then it has to be like on the upper side, but also on the left.
Yep.
Right.
Yeah, because the point was -3, so that's why we're here. But then we know it was 3, which means it's above the y, the horizontal asymptote. Scroll down.
But don't the negatives feel flat?
Yeah, +3. That's why we were up top. Right? 3, +3. 1, 3. So then it would have been like right over here. I moved it a little bit, but I just got a general idea. So when we did 1, 2, 3, 1, 2, 3, it would have been like that. You wanted me to scroll down? Yeah, we're good.
10-minute mark is all it was. I think.
We have 10 minutes left?
Yep.
Okay, so I'll show you Desmos and then we will call it a day.
Let's go.
All right, let me show you this in Desmos.
Okay, 10:49 a.m. Eastern time.
All right, I'm going to put in our original function. So y is equal to x squared minus 2x divided by x squared minus 4. Okay, doesn't the idea of it look very similar to what we had? We had a vertical asymptote at x equals, what was it, -2, right? There's our vertical asymptote right here. I just entered it in for you. Now, it doesn't look like there's an open circle, right? Doesn't look like there's a hole. Look what happens. It's just not showing you. So we were supposed to have 2.5. Do you see that? When I go to the graph and I click it, see how it's an open circle there? It is undefined. It's telling us that point is undefined. If I click on any other point, look what's happening. Are they giving us coordinates? Yeah, but when I click on this, it is telling me it's undefined. Pretty cool we were able to figure this out all by ourselves, isn't it? All right, we are done for